So let's take the functions we were dealing with before. Show that these two functions are inverse functions. So what I'd want to do is compose them both ways. So first I'll do f of g of x. Well, that's f of, well, g of x is x plus 5 over 2. But doing f to that says take 2 times it and subtracts 5. So do 2 times x plus 5 over 2 and subtract 5. Well, we see the 2's cancel. I get x plus 5 minus 5, and I get x. Okay, so I did f of g of x, and I got x out of it. All right, let's do the other way. G of f of x. That would be g of 2x minus 5. But g says, take what's given, 2x minus 5, add 5 to it, and divide by 2. Well, that would be 2x over 2, and that would be x. So in both cases, I did get the composition to give me x. This means that f of x being 2x minus 5 and g of x equaling x plus 5 over 2 are inverses. Okay, so what else does that mean? So like we said before, we would see that if you put f of 3 in, you put 3 into f, that's 2 times 3 minus 5, that's 1. And because they're inverses, if you put 1 into g, 1 plus 5 over 2, you get 3. That makes sense, being inverses. So 3, 1 is on the graph of f because you put 3 in, you got 1 out. And 1, 3 is on the graph of g because for g you put 1 in and got 3 out. So let's see what that looks like. All right, let's try and see what we have here. So if we had 1, 2, 3, and we had 1, 2, 3 in y. All right, so let's see where these points are. So we said you get, there's 3, 1, the point on f. Here's 1, 3, the point on y. So if you have two inverses, if you have f and g and they're inverses, then when the point AB is on the graph of f, the point BA is on the graph of g. And what are we really seeing? We're actually seeing that these are places along the line y equals x, where you wouldn't even notice such a switch because the a's and the b's are the same in that case. So in this case here, things would stay right as they are. Everything else ends up being a reflection over this line y equals x. And that's what we've stated here. If g is the inverse of f, then the graph of g is the reflection of the graph of f over the line y equals x. So let's see what this would mean for an example. All right, so let's first calculate the inverse, then we'll sketch these and we'll see if what we find is true. All right, y equals the square root of x plus 2. I'm going to solve for x. All right, to solve for x, I'm going to need to square both sides. Y squared is x plus 2. But I have to be careful because in this original thing, in this original function here, y equals square root of x plus 2, y would have to be positive because it's equal to a square root. When I went down here and squared both sides, I brought in more that wasn't there. Now y could, in theory, be negative, so I have to make sure that in order to keep these the same, I say y is greater than or equal to 0. All right, so that means now if I solve for x, get x is y squared minus 2, again for y greater than or equal to 0. Then I switch x and y, so I get y equals x squared minus 2 for y greater than or equal to 0. That means that's my inverse. Whoops, this should have been switched x greater than or equal to 0. Okay, so let's take a look on a graph here. Let me try and get a pretty nice graph here. So let's say 1, 2, 3, 4, 1, 2, and 1, 2, 3, 4. Okay, so let's take the first thing. Y equals the square root of x plus 2. That's a square root graph that's just been backed up, shifted to the left 2. So that's over at negative 2. And that's going to go through and do this. So that's going to go like this. All right, because let me try and get that a little better here. Okay, I think that's pretty decent. All right, so that's y equals the square root of x plus 2. Now, let's take the inverse. X squared minus 2. That's a parabola shifted down 2. So that would actually start, let me extend this a little here. That would start down here at negative 2, and it would go up like this. Whoops, I bent a little too far there. Let me fix that. Like this. This would be y equals x squared minus 2, and only the part when x is greater than or equal to 0, so we don't get the other wing of that. All right, well, look at these two things. Aren't they indeed, if we look at the points y equals x, that's this line right here. And these two functions that we sketched were actually flips over y equals x. So that's how they're related. So yes, these two functions have a very nice relationship. They undo each other, so that when we put a value into one and get a result, we put that result into the other and get back the original value we started with. Graphically, they are a reflection over y equals x. And that's what we have for inverses.